Okay, so now we're going to go into how to interrogate claims, right? So as a researcher, you're not only making claims, you're questioning claims and evaluating whether they're accurate or they're reasonable given the data and evidence that the person making the claim has. So first, starting off with a frequency claim, we want to focus on construct and external validity. So you can see on the bottom right there, I have arrows pointing to construct and external validity. You only have one variable to consider, so you're evaluating the validity of that one variable, right? And you have these two constructs, or these two validities to consider, the construct and external. So when we're doing this and evaluating construct validity, we're asking, did they measure, again, what they said they're measuring? So this involves digging in, right? Looking at, well, how did they actually measure? Did they use a self-report? Did they use a observational measure? Did they do some type of physiological measure, right? Where you can measure people's actual heart rate directly using some type of machine, right? So you have to consider, well, how was it that they're measuring it? And given what they say they're measuring, is that appropriate? And just to give you an example, here you have a finding. You have a finding that a claim that 75.2% of CSUN psychology majors are female. And this was in fall 2016. So let's say I'm making that claim. So think about what you would ask. Think about what you would want to know to see if they actually measured this correctly. And keep in mind, you're looking at the tools they actually used to measure whether people were female, male, or had other gender identities. So some of you from gender who have taken gender studies courses might have some really good critiques of this measurement. Now, when thinking about external validity, we're thinking about, does the sample, does that accurately represent the students on campus? So let's say I recruited 10 students for my class, or let's say my whole class. I recruited one class, measured their gender, and based on that, I got this the statistic you saw on the previous slide that gave me an idea of how many females we had on campus. That wouldn't be too good, right? Because based on 30 to even 50, or even if I had a class of 200, we're a campus of 40,000 students. That wouldn't be a representative sample. That would also only be in psychology, right? We tend to have more female students. So that's another issue, right? So consider, based on how they recruited their participants and who they recruited, can they generalize their findings to all participants? In my example, it would be to all students. And now we move on to interrogating association claims, right? So now we're specifically focusing on two variables. We have two variables to assess now. Before we only had one variable, now we have two variables, and now we have three validities to consider. So before, we didn't have to worry about statistical validity because people were just reporting percentages. Well, I said people, but in those situations, you're only reporting percentages, frequencies. When you're reporting associations, you have to have at least a correlation. That requires a statistical test, so keep that in mind. So now we're assessing construct, external, and statistical validity. Okay, so construct validity, same thing. We're asking, well, how well did they measure what they said they're measuring? Are they actually measuring what they said they're measuring? Not only how well, but are they actually measuring it? And if you decide that one is poorly measured, you can't trust the conclusions, right? So this is what you would assess in this situation. You're just doing it now with two variables, right? So for example, in this case, you have an example of association. Breathing problems during sleep are linked to depression. So you would assess depression. How well did they measure depression? What did they use to measure depression? Did they use a test that has been standardized in the field? Did they make up their own test? Did they have an expert interview this person and assess them? You have to look into it and figure that out. And then also, for breathing problems, that's our other variable, how is that assessed? Did people self-report? I don't know. If they were self-reporting breathing problems, is that accurate? I would want an observational measure in that situation, because if you're sleeping through the night, can you really remember all your breathing issues? External validity, same thing as before. You're looking at the sample, the size of the sample, and how representative the sample is of the population of interest. You might keep, you will keep hearing me say population of interest, because I want to make it clear to everybody that I'm not talking about every single person in the world, right? That's not who I'm talking about. When I say population of interest, I'm referring to the population I'm interested in working with in this study, or that the researchers are interested in working in their study, right? So if I'm claiming I'm doing a study to better understand students, university students' sleeping patterns, well then my population of interest is all students, all university students. If I said I'm interested in CSUN university students specifically, then that would be my population of interest. So you're seeing, based on how they recruited, who they recruited, can they generalize these findings to the population of interest? Some red flags, well, they recruited only at one specific time. They didn't do a good job of randomly recruiting participants. They recruited from only one major, one gender. Some genders are overrepresented in the sample, meaning they don't reflect what the population looks like. So if you have 60% female students, your sample should look like that. Now, for statistical validity, here we are looking at we're taking additional measures and questions into account, or we're asking additional questions. We're asking, well, how strong is the association? Now remember, for an association, you're thinking about a correlation coefficient. If they're saying there's a strong relationship between reading and intelligence, but then they have a correlation of coefficient of 0.3. So, go back and draw back on 320. That's a very weak relationship, right? If they said, oh, there's a strong relationship, and they have a R coefficient of 0.8, great. And then some, just intuitively, you can kind of see whether there's a strong relationship, but we shouldn't actually rely on intuitive understandings. We should go into the research and actually do the analysis. So here's two examples. So you might have a study that compared calorie consumption and weight. So there might be probably a strong relationship. You probably would have a high R coefficient. That next bullet, calorie consumption and income. Now, there probably is a link, right? There's been studies that have shown there's a relationship between income and the types of food you eat, healthier food, things like this. It's not necessarily tied, but there is a relationship. But most likely, it would be a weaker relationship when compared to something like calorie consumption. There, in a way, you might have a more direct or a stronger relationship than with calorie consumption and weight gain. So actually now I'm noticing in the example I had calorie consumption and income, that might have a strong relationship definitely as well, right? But I think that second example I gave instead actually works better, because calorie consumption is strongly correlated with weight. Income and weight actually probably not as strongly correlated, But there is a relationship there, right? Because you might have access to healthier food or gyms or even workout equipment, right? But it doesn't mean that you can't be at a lower weight and be low income, or healthier weight, I should say, right? At least in the U.S., right? So what does it mean to say that an association is statistically significant? Well, we're asking again, looking at that R coefficient, right? The strength of that R. Did the researchers make any statistical conclusion errors? So again, I just want you to broadly understand this. So did they make any errors in carrying out the study? And given their findings, are they supported in the claims they're making? Right? So if they have R of 0.8, which is a strong relationship, they're probably supported in making the claim that there's a strong relationship between gaming and violent behavior. But if they had an R of 0.2, then they're not on really good grounds to make that claim. Now, for causal claims, causal claims are specifically focusing on people making the claim that one variable leads to, causes, changes in another variable. It's not saying that there's an association. Remember, association claims, you're just saying, well, as one goes up, the other one goes up too, or as one goes up, the other one goes up. But we're not saying this one causes this one. We're not saying that income causes intelligence. But let me rephrase that. We're not saying that income causes educational attainment, but they're highly related, right? Now for that one, it's harder. Let me give you a better one. So let's go back to this one. So when we're making an association claim, right, we're not saying that playing video games and violent behavior are caused by each other. We don't know which one's causing which. We don't know if violent people are looking for more violent video games or if violent video games are making people violent. So that's an association claim. A causal claim would be a direct claim. Playing video games makes people violent. So one thing I do want you to make sure you all know are the three rules. The three rules or requirements to establish causation. You do need covariance. So covariance we even have in associations. Again, covariance just means that as one changes, the other one changes. Keep in mind this could be inverse. One could go up and one could go down. More studying, better grade. Less sleep, worse grade, right? They're moving together. More partying, worse grade. Or actually, in the case of most students, more work, lower grade. Because most of you are just really busy. More procrastination, lower quality, right? That goes for all of us. So you have a relationship, you have covariance. They vary together. And it could be positive or negative covariance. Well, I don't want to confuse you. It could be negative or positive association, just to stick with the terms we've used before. You also need temporal precedence, meaning that if you're making a causal claim, if I'm making a claim that caffeine causes greater attention, that leads to greater attention, then the caffeine has to come first. If we're thinking of time as like a timeline, caffeine has to come first, then my measure of attention. It's as simple as that. Your IV that you're claiming causes the DV has to come before the DV. You can't really establish that in correlational studies or survey studies, for example. If you're having people do surveys, well, it's hard to establish that the IV came before the DV. Now, internal validity, that one's tricky, right? So I did go over that, but that one's tricky. But you want to make sure that there's no alternate explanation. So if I'm claiming that caffeine increases attention during lecture, this gives all students caffeine, then there should be no alternate explanation to that claim. There should be no one that could come along and say, well, no, not really. Look at the design of your study. You had all the people who took caffeine take this to participate at 2 p.m. and all the people who took decaf participate in your study at 7 a.m. It's not so much that caffeine increases attention, it's that you're getting the sleepier students or the students who have just woken up in your decaf situation, right? So there should be no alternate explanations. So in measures of intelligence and educational attainment, people will often bring up, well, it's not so much that these students are better or more committed, but students in rural areas or low-income areas have less access to quality education, right? That would be a third variable. If a researcher is trying to claim that students in cities or in affluent areas work harder, look at how well they're doing, and somebody brought up that issue, well then that's calling internal validity into question. We have to check for all the validities. Yes, we have to check for all of them. So I'm going to go through the first three quickly because we've done those before, but it's the same thing as before, okay? Construct validity, we're checking how accurately they measured at least two. So just like an association claim, you have to have at least two variables, an IV and a DV, right? Now, here's where you have kind of a switch. One IV has to be manipulated, right? So not only are you looking at how well did they measure those variables. So if I'm measuring attention, you're looking at, well, how well did he measure attention? Was he looking at how much time the students had their eyes open? Was he looking at heart rate as a measure of attention? How accurate is that? And then caffeine, my other variable. Well, how well were those two levels of that IV measured? Right? If I have control, I give one student 5 milligrams of caffeine, another student same amount of liquid, but decaf coffee, right? So that's how I define it. You look at it like, well, okay, that looks pretty good, the way it's been defined. Now, the IV, because it has to be manipulated, you have to look at it closer. Look at it closer and see, is there some evidence in the explanation, that's where you should see it in the method section, that the researcher randomly assigned, or at least was able to assign participants to the levels of the independent variable. That's what it means to manipulate. I'm able to assign some students to the caffeine situation and some students to the decaf situation. That's a manipulated variable. If you're, how should I say this? If I'm comparing students who came to class and I just asked them, did you have a cup of coffee? And then I compare students who had a cup of coffee to those who didn't have a cup of coffee, I can still compare that, right? I could still compare, well, let me look at the students who had a cup of coffee and see how awake are they during lecture compared to the students who didn't have a cup of coffee. I can do that. But in that example, I did not manipulate caffeine, right? They already came with caffeine. I, as a researcher, did not choose who gets caffeine and who doesn't. So to have a manipulated variable, the researcher should have the ability and should have assigned participants to the different levels of at least one IV. And again, it should be the IV, so keep that in mind. Now, in terms of external validity, same thing, you're looking at the sample. You're looking at the sample and deciding, given the sample, what claims can this researcher make about the population of interest. Does a sample, does it look representative? Does it match up somewhat, to some degree, to a high degree ideally, with a population of interest? Was there effort put into that? That's what you would assess for external validity. For statistical validity, I feel like I'm losing the ability to say that as we go. But for statistical validity, you're looking at, well, are the claims appropriate given the findings, right? So are there any errors in interpretation? Did they use the right test? Now, for statistical validity, I'm not going to go too much into that other than you should understand these two things. Did the researchers, you do have to assess, did the researchers make any errors in the statistical test and interpreting the findings? Later on, we'll get into what kind of statistical tests, but not for this chapter, actually not for this exam, right? We're not going to go into p-values and that sort of thing. Yeah, so I'm losing my voice. Good thing we're near the end. So the fourth validity, okay, so the fourth validity we want to take into consideration is internal validity. So just as a reminder, to establish causation, right? So going back to that earlier slide, to establish causation, we have three requirements. One of them includes establishing good internal validity. Now, in these previous slides, I've been showing you how to assess validity in a causal claim, which is something you should do. But these 3 points are as important, right? You need these to establish causation. So not only do you have to establish that there are no alternate explanations, right? That yes, definitely is caffeine that's increasing attention, and it's not time of day. But you also have to take into consideration covariance to establish causation, right? Meaning your variables move together or inversely. One goes up, the other one goes down, and your IV has to come before your DV. But just going back to that fourth validity, you have to make sure you're able to establish internal validity. And when you're assessing that in a claim, you're really looking at, did these researchers do a good job of ruling out any alternate explanations? Can you think of any alternate explanations? So I'll go ahead and stop there. Let me know if you have questions.